Okay, so that's the middle part. And the third part is, given that we have the underlying theories and also indicators, what are the signals will translate that into visual patterns? So we don't look for other more complex signals. Instead, we simplify those indicator signals just to flash to us, said flag, this is something you need to pay attention. So that's the point we try to send to many users with this assumption that domain knowledge is minimal. Probably they don't have any domain knowledge at all. So in this case, we need to tell them probably two things. First, something important is happening here. So that's the first thing. We don't need to have domain knowledge to understand that. Everybody is a flag, red flag, something important. Secondly, we need to allow them to investigate, explore further. So what's really going on here? You said something important. That's your recommendation or suggestion. That may not be the case. So here's your technique, your tool, instruments, and go figure out what's really important or not. That's your judgment. So this is journal 3 blocks to complete this workflow. Starting with what we're thinking, the theories, the guidance, and then looking for anything that stand out, visually stand out, and then go there to dig deeper to understand, is there something really happening or not? So that saves us lots of time. And also I'll include several case studies to see how far we can go without highly specialized domain knowledge. So certainly it will be a luxury if we have domain expertise accessible to us. We can ask expert, it's available. But if we don't have them, how much we can do? So this is the journal guideline or framework. So if you want to know more details, here are a few books. You can check the details. The one thing that influenced my thinking quite a lot is what is the fundamental or common task that every researcher they have to deal with. So one thing is, how can we keep up with the state of the knowledge? So everybody publishing their work as fast as possible. So how can we know what is the best place to look at? So here are a few questions. I'm only interested in the second question, which is, if you have a research question, what has been done so far? So what others have been studied and proposed good ideas up to this point? So that's not easy task. Lots of time, we all know that related work, we have to cover enough ground to justify our work is really new enough and different from others. I also have some advantages over existing ones. So another piece influence our thinking is really the activities of individual researchers. They have to communicate. Not that they have to, they probably, they better to communicate their work. Otherwise, if they keep their work alone, there's no impact, nobody knows, that's no good. So combine this together, we're thinking about this. If you look at from this perspective, what is every researcher's basic fundamental task, everyday task, is basically make the argument that what they're doing is special in a reasonable context. So put it simply, that's the work they have to accomplish. So these two layers, you put it together, you see the commonality here. You have to answer this question in a very convincing way by all this knowledge, what's happening up to this point. So this is two of them very influential work. So from this perspective, we have this user, this could be anyone without domain knowledge in this position and to answer this question. If you do it well, peer reviews will have nothing to say against you, but you can have more productive time. So go from this initial orientation. So here's very quickly what we know about what are the challenges we're dealing with. We have too much information. We also have too little useful information or knowledge. So I guess this is the right audience. People will know what I'm talking about. This paper mountain on the left here. So lots of publications, but the really relevant ones and useful ones to us is very small part of that. So here I have a quote I like for now. He has this social function of science. He has a lot of nice insights there. So I just quote a few of them. Here is one that the pressure already feel. How many papers published every day? How do we determine which one we should spend our time on it? So the consequence actually is quite serious. It would spend our time on the right papers, we'll be more productive. If we spend on the wrong papers, not only we're not productive, we can hurt ourselves because we only have the limited time and limited resources. So this theme of the limitation or the tension between what we need to do and what the time, the resources we have, you're going to see the recurring several theories. We're going to talk about those theories. Here's the chart. Here's a chart to show how much challenge this could be even to a group of experts. So a group of experts, they publish paper, they cite references. But from there, you could see an alternative view. Could they position in a slightly different way or in a fundamentally different way in the landscape of a big, larger context? So in this way, you can have this tool on your desktop to help yourself. You don't have to go to an expert to get that. You can get instantly. So in this way, we provide an alternative view of the world. So that will tell us what is the position, which area we should be looking at, which area that already looked at by lots of others. And for example, like career planning, strategic planning, you can decide whether those area you want to spend the next 5 years, next 10 years, or you don't want to do that because people already too crowded in those areas. So this is just one example. So to put all these theories together is similar to this question, what is an elephant? So in this case, the elephant is the science, or science is the elephant. There's so many different perspectives, philosophies, sociologies. They're fundamentally different because they pay attention to different aspects of science, the same thing, but interpretation is quite different. So we're going to look at them if assume the assumption is this. There's so many theories. You can take any one of those, your favorite one, to replace any one of these. And you may get different indicators. You may get different stories. But the point is, you have this framework of thinking as long as you have theory there as your reference. The theory, you don't have to fully 100% believe in the theory, but you just say, here's the theory. Given this theory, what I should be looking at and what can I expect I should see. If this theory is true, I will see this. If I don't see this, I mean, few things. It may not be true, it may be true, but the data or some steps could be wrong. So those are lots of interesting things you can interplay with the theory on the one side and indicator on the other side, and you can have your own conclusion. You can also predictively to think about if the theory says on the east there's a block area, that's really important. It's supposed to be important, and you can watch those areas to see any traffic there, and you see here you will have a competitive advantage over those who don't have such theory, such guidance. So this is the role of the block, the theory part versus the one you can go in without any theory. So this is the elephant part. Which part is the arms and legs? So I start with this scientific revolution. This is almost everybody knows. Lots of people knows probably much better than I have. So here's one example. This here basically said we have the paradigm, currently have a paradigm. Suppose that theory is true and people influenced by that paradigm, you can expect there are some common patterns or features from there. They behave, there's some commonality. Otherwise, you can't see that they have a common underlying paradigm behind them. So from there, you can also think about what would happen if people change the paradigm. If have different paradigm competing with current one, would you, in terms of citation behavior, would you cite the same materials, or would you cite different ones, or would you cite both of them? When you have a fade, when you switch. So those are the things from the theory you can derive the kind of things you can observe. So that was the philosophical perspective. Things are changing. From a sociological perspective, and this is also a very influential one, at least to my work. This one has the idea of attention space. So basically, it says the attention is limited, like all other resources. So in other words, if the attention is limited, we can't give equal attention to all of the available work. We have to be selective. So if we do that, we emphasize different things. And also from human nature, you think about it, researchers, what they care the most is the priority of novelty. You have to show this is new. You also often see this kind of statement. This is the first of whatever in whichever field. So that's the claim of novelty. So to claim that novelty, we can use this sociology, the attention space or the attention span to indicate what people would do. What are the strategies will be most effective if you have driven by these kind of things? Which one will make it more efficient to get you that novelty, to get you this attention? So here, a very nice example, lots of them. He did lots of work on these kind of networks of thinkers, philosophers, and a question like this. So where are the greatest philosophers in terms of social connections, intellectual connections? Where's the best place to find them? So in this case, it's like you see those kind of lines, conflictual lines, those are the areas where someone is fighting with competing schools. Those are the ones tend to be the most famous philosophers. So that's give us a one clue where we look at. We'll have a big network of philosophers or thinkers. So that's the kind of thing we want to present it to ourselves. This is the big map. We're not going to pay attention equally to all the nodes in the network. Instead, we're looking for those highlighted areas. Those are highly potential areas. If they do something, say something there, will be much more influential than anywhere else. So those are kind of the guidelines we're going to look through. So another theory, this is more from HCI, human interaction, but I borrow this theory. I found this very nice to explain human natures. But this one is pretty pragmatical in terms of information foraging. So originally the theory is from optimal food foraging. And so we start from animals looking for food. What a strategy to do that. So I think the information foraging is similar, but I stretch even further to use it here is information foraging for research communities. So how long is research community going to spend their time and resources on a particular problem, on a particular research question? If you spend it too long, depends your entry point, what is status of that field? Maybe it's profitable. In this case, the indicator here is profitability. It's like how much return you can expect if you enter this field at this point. If you enter at the very beginning, you get lots of benefits or competitive advantage at that point. If you enter later stage, everybody is prepared to leave and you lower your possible return. So this is very practical one. We're going to show some examples later on. So this is another one. This one is from very generic problem solving process. We can apply this to different level of development of a field. So basically, there's a problem to identify, conceptualize a problem. And then once we know what is the problem, it's clear. The current available tools are not good enough. We have to specialize, develop some tools that can really accomplish things. For example, for astronomers, they just need a special telescope to accomplish that. So if we don't have that one, we can't solve this problem. So that's the second stage. The third stage, once we get that powerful tool, we need to basically apply, very logical, apply that tool. So also that given a tool, we solve the problem, apply the tool. What we see quite often is also people with a powerful tool, they tend to apply this tool to other things. Sometimes very surprisingly, they never expected by the original thinking. So everything could happen. If you apply a tool to something new, somewhere new, then you can generate new problems from there. So that could be a point to branch out for another new field, new ideas. And so the last stage is vacation, the lessons learned, anything we learned so far, what works, what didn't, and people write up textbook and tell us this is something you could do. There's something you could do within 24 hours, 48 hours, and so those are the experience we have. So nothing really new, novelty claim is getting really, really low to that point. So again, back to the science, generally speaking, is researchers, they don't really study any research problem, unsolved research problem. Even some problems well known, unsolved, people just don't go spend the work on it because even if solved is not, it's trivial, considered trivial. So in terms of competition for this novelty, you don't get much of a return. So that's the sort of problem people see, people will avoid. But can we actually see that based on the data? Can we see those patterns when people stay away from there? So that'd be something really interesting and help us in a big, higher level, strategic level. So if people leaving away from this area, and maybe you can decide, maybe that's exactly the area we want to get in. Nobody else there. Competition is really low, but that could be a good timing. But otherwise, common sense, follow others, that's another option. But the good thing is, if we know these kind of trends, know these patterns, then we can make a better informed decisions. And we can also go back here, apply this process again and again to provide more information. That's what we call the meta-knowledge. It's the knowledge of knowledge. So it's not really on the publication itself. It's about why people choose particular area and why, when, how long they spend on this. So to translate that problem-solving process or model into this, what we expect to see is there's some specializations. Each line, I'm going to explain more about this. Each line, they're specialized on something. They have a specific role. For example, one line is specialized building tools. They're building telescopes, for example, how powerful it's supposed to be. And the other one is supposed to be one about problem, characterized problem, conceptualized problems. And the third one could be application. Given a tool, they apply the right problem, even apply to the wrong problems, as long as it's new. So everything could fall into this framework. We can identify what are the stages currently people are engaged. And also very interestingly, how to different researchers, they have different preferences. People maybe simply just enjoy building tools. They don't like to apply. They just like building tools. And here you go, their tool, you can go ahead and use it. Other people use it. I'm going to create next tool. So different kinds of people can fit in their own strategic preferences into different kinds of frameworks. So they all have practical implications in this. So here's another talk, the quote from Burnell. There's so many things, attention is limited. Where should we pay our limited attention to? So some places, here's one example, is that you look at science, it would divide the science into different regions. Some of the part maybe at the center of a region, depends where our attention is supposed to be. Maybe between different regions. So here's a clue here. Between the regions is somewhere underfunded and somewhere underrepresented, and the resources are not really allocated adequately. So those are one area of the problems. And on the other hand, we can also decide, depends on your expertise. Is it better off if you look at the center of a region, or are you better off to look for some more opportunities between those different regions, and what are the possible scenarios can play out from here. So here's consider the one example. The NSF, they did a project they call the traces. So what they did is found the inventions, what leads to inventions. They found quite amazing is there are lots of parallel lines, parallel developments. So parallel developments and the lack of communication between them until almost the last minute. But once they communicate, they have an invention. So that gives us some ideas. What can we do to make people start to pay attention to communicate across different parallel lines? So we're going to translate these parallel lines into some fields, subfields, and then to look at the communications between them and the possible or potential communication between them. So once they communicate, they can start to merge together. So two parallel lines becomes one. So that's one of the important patterns we're looking for. Because of this, we know that if we merge, if we have a communication between them, we're more likely to have something worthwhile, more profitable. So here's a quote, basically say that that's something really hard to do beforehand. How do we know what we don't know? Or it's the best part, which is communicate. So yet another theory. Lots of theories that we build together, and then the next step is to identify if any of these theories true is correct, what can we expect given all the data, real data. So here's one says, this is called the structural hole theory. It's a network, especially it's originated from social network. In a social network, the locations, there are some special locations. The value, the potential, they're not equal. Again, so that's will be consistent with our attention is limited. We don't have time to look at each one of these links. We only need have time to look at the most important ones. So here's one suggestion. The most important ones tend to be the bridges, or in the areas, those are called the structural holes, which is you don't have all the possible links you should have. Instead, you have fewer links, and then you can imagine the traffic will go through those bridges. So imagine if you remove those bridges, there's no communication between them, no traffic. And so that's the role of these areas. So obviously, this one is telling us we should pay attention to this kind of structural hole areas to look at the traffic going through there and which one is supposed to be the pioneering and which one is supportive follow-up. So we can go start from this framework and tell us what we should pay attention in this limited area. Another interesting part is studies they have found if you don't have this knowledge or don't have this concept to begin with, even you look at this network, it's in front of you, you may not pay attention. You don't know this concept, you're not looking for the right thing. So that's important to have this concept to build in our mind first. So our mind will drive us to see, oh, you should look for those bridges, the structural hole. Otherwise, people will overlook. Here are some examples. People may not be particularly interesting to what I'm looking at, the network. But here, there's something really, if you only have 5 minutes, limited time, you should look for those bridges, looking for that, the links. They're supposed to be lots of links, but you only found one of them or even none of them. So this is the guidance from all this theoretical thinking. So that's the theory, meta-knowledge block. We have all this built together. We think about, given all this, can we combine them, integrate them, so that we can take the data and generate some indicators to say, here is lots of bridges, looking here. And so the users can go and dig deeper to investigate what is possible, why that could be important. So very briefly, the design is like this. What you imagine is like you have a data. Just imagine you have a pile of data there. You have a camera, and the camera takes snapshot once for a while, every 1 year, every 1 month, depends on the data availability. And then you can have a lot of snapshot together. That can be a video of your historical development of your field. And you're going to see that from the beginning, the people citing one particular pile of references. And then after a while, there's some special time that people tend to stay there for a while. But suddenly something happened. Then you see a switch. There's a pattern. Everybody's leaving this area and go somewhere else. And so here are several practical questions. Where are the people going to somewhere else? Why are they going? What they take with them? So those are the interesting we can expect from this kind of basic, very basic build up from the local information to generate global ideas. And then we have those knowledge behind, so we can use this knowledge to interpret. Oh, here, this is what the theory X is telling us. We should follow up with the theory. So what's next from this initial indicator? So here's what it look like. Different continents in different colors, something in between, connect them. And so I'm going to show you more examples of that. Here are some other examples. I'll go back to explain something interesting here. So this is, again, the framework of the whole entire process what we're dealing with. We think about science or the knowledge, scientific knowledge, as a complex adaptive system. So that means very complex that adaptive system is, we can consider lots of different types of input. So we have publications as input, we have retractions, that's also input. The knowledge links you build by one publication can be destroyed or removed by retraction, or maybe not completely removed, where somebody didn't know they have been retracted this paper a long time ago. So to different people, the knowledge, the picture of that will be different. But the adaptive is you have lots of publication that keep emphasizing one bridge. That bridge is going to be very strong, very wide. The traffic going to, lots of traffic can go through there. So if you have lots of traffic between two continents, that two continents will emerge, become one. So the structure, global structure could change. So in that sense, this is a complex adaptive system. A tiny change, you don't know the consequence. Now, one paper published can suddenly change the whole structure. But on the other hand, you can publish 100,000 papers that doesn't change anything. The global world structure remains the same because you're always working within those continents, within the regions. You don't change the bridges and everything else remains the same. So here's some examples of indicators. From the outside, nobody needs any domain knowledge to know there's something wrong with the system or something happening inside the system. Here's one example, is the information entropy. If you look at the system, a body of literature, there's an entropy jump in two cases, two occasions. If you don't know anything about it, you just know internally something happening. The knowledge dramatically change during or between and these two periods of time. So that's the first question we need to tell ourselves, our researchers. There's something important happened. It's really time to look at, to update your knowledge, because if you miss this one, your knowledge already out of date, because at least by this indicator, lots of new materials added here that's quite different from what you know in the past. So to translate that structural whole theory, instead of we're looking at a social network, we're looking at a conceptual network of citation. Actually, it's a co-citation network. So people co-cited. So the area we're looking at is structural whole around structural holes, and the bridges, and the one that connecting to different files, different communities. People supposed to be talking about different things, but what is the traffic between them? And remember, this is co-citation. The traffic between them, the citing authors, they must know, they are aware, both of them, at least both of them, both sides. So there could be a new idea to make a new connection, innovative connection. These two are not really connected so far at this point, but you make a new contribution. I believe they are the same thing. So that will be a very valuable co-citation instance. So another kind of indicator here is we know that between two regions, if we have too many links between them, they become one. So if lots of users or lots of scientists, researchers publish things that consider connections between them, that attract them, become one. So if this happens, that means the body of the literature has something significant change inside as well. So this indicators is measuring in terms of blockness. If the big block become two single block, that's a lot of change. So if that change happens, like the indicator suddenly drop, you know, something new, something revolutionary is supposed to be happening. That introduce two blocks getting together. So this again outside we see we don't really need any domain knowledge to understand this. There's something important happen that anybody can understand. You go on the street and tell anybody something really important in physics happened. Okay, that's brilliant. Exactly how you appreciate that, how important, that's the second question. So we need to first draw attention of the researchers. There's something really happening here. Then we can draw down which particular publication, which paper, the idea in the paper, the claims in the paper. And then we go down different levels of this granularity. Then here, interestingly, we analyze this. We don't have any domain knowledge. That's our intentionally testing this kind of methodology. Is we don't assume we know anything about it. So we deliberately try different areas we know nothing about. And then we can follow the indicators that guide to us. Something happening, look at which one are responsible for such indicating significance. So here's one, we kind of beat the Nobel Prize announcement by 6 months before that. So we can't cheat because we did it first and we follow the indicators. So that's a very encouraging exercise. We know that we don't know any domain knowledge. This will be much more helpful for any domain experts. They know clearly something happening they can explain. But here, this is what we lower the threshold. Given the data, we don't know anything about it, we can identify the same thing, at least 6 months is 6 months. It's really an advantage showing us we can work on this to build our own plan, research plan. So we're talking about the regions and the bridges, how the bridges can impact the structure. The structure of science, now we're talking about the regions, the blocks. And we're also talking about the parallel lines. So if we have lots of bridges stitching together those different areas, and then they'll become one. So in here, we have some examples. You can see here, this is the area. I have a red arrow pointing this area. This is emerging field, a new island. So what they did is they cite the bridges. They contribute lots of traffics, new traffics on new bridges. Those new bridges connecting, see here, 2 or 3 different regions, different blocks. Before that, the blocks are separated, no much traffic. But here, these are the groups that are responsible for building the bridge. We have the traffic. You can imagine one day the traffic becomes so much that nobody is surprised anymore. So it's already well known. But that moment is before they have the publication, and compare with after they publish this, there's a fundamental structural change. So this is what's called a structural variation. So the most valuable information we're looking for is which one is responsible for such structural change. So naturally, that would be another kind of a evaluative criteria. This is important because that one changed our beliefs, changed the structure of our beliefs, and also followed by lots of supporters, lots of followers, and they strengthen the change even more. So you make the first 10 stitches and 100 followers, they make consolidate all the others. So eventually, and there will be no more old structure now become new structure. So this is a switch from the old view to a new view. So here's another example. We're looking at a Nobel Prize winning. This is 1971 publication, and the Nobel Prize was announced 2014. That's many, many years after. So what we can go back time to see in terms of citation behavior, what is special? Or what was special at that time? So interesting because of theory, we have two blocks, two regions, and there's no so much traffic between them, no bridges. But this Nobel Prize winning paper actually adding lots of links between them. So this is consistent with our expectations. The innovative work, the highly innovative publication, they supposed to add these kind of contributions to change our beliefs, to change the block of science. So this is just one confirmation example. We see lots of links added at that time. This is another very quick example to show the attention span. So we know the focus of attention is changing over time. The attention span is how many years we look back, how many years researchers in their citation, they look back. It's changing, it's different, depends on time. So that means, suppose you can't say something like researchers always look back 5 years, look back 10 years. That's not the case. Actually, more accurate is say researchers, how long they look back depends the internal structure of how well that field is developing. So sometimes they need to look shorter because it's in a relatively stable stage. But when things get troubled, it's like in Kuhn's sense, in a crisis, they look much longer to find somewhere they can put their foot down. It's longer, 20 years not enough, 30 years, 50 years. So now we see that sometimes narrow, sometimes wider, and that's another way to tell us something going on in the system. And you can use this as a guideline. So you look at it like 10-year period, you should probably looking at like 12 year, 15 year, that should be enough. If in your time period is going back 50 years, that's in a very interesting time. You should look back maybe 60 years, 70 years. So that's another way to look at how people or how the community shifting their attention. So there are two ways to shifting attention. One is where, the other one is how long. So there's different ways to look at how the science, the landscape science can be divided in different ways. It's interesting that once we see this way in 5 minutes, okay, I will speed up in 5 minutes. Catch my breath. So in this way, we can see different fields, how, doesn't matter which level of granularity, you can always divide them into these kind of parallel lines. Remember the first one, parallel lines, if we can communicate between them, something important tend to happen. But these are the building blocks. So we'll see this again and again. We'll apply different fields, you see parallel lines. But the question here is, how, if you choose one of them, for example, if I choose the red one, how long are you going to stay there? It's already happened for 10 years, whether I should stay there. A more important one is whether you can build any connections across them. So those are the bridges. That will change the structure, and that will give you more visibility, and you get more productive if you follow that kind of suggestion or ideas. So going there, we can identify some patterns, how you can join those parallel lines. So several examples. I'll speed up here. Basically, independent is you stay parallel, no communication, everything go as usual. And then can diverge is you have one that split into multiple directions. That's another possibility. You have a third one is merge, different lines going together and then cross over one side to the other. So we can tell this by using this, and this is called duality overlap. You put a one layer citation behavior there. So basically the one, let me go for this one. So this is called divergence. So the citing papers on the left and the citing what they cite what is on the right. So that means 3 different communities, they cite the same thing. So that means we have a divergence pattern here in this case. And this one mergent, the citing here cite different sources. So this is obviously a different pattern. So they draw the ideas from different parties, but then they have a single common thread onwards. So this one is the same. This show between the regions, the links are important. So here we can identify papers that really adding lots of lines. The red lines, you see, they're all between regions or between clusters. We know theoretically, they tell us there's something supposed to be more important to pay attention to those lines. So here's a shift of focus. This one's indicators and the bars. You see this first period is quite stable. So lots of attention is paid on one theory out of 8 possible theory. This is mass extinction, by the way. But after some point, suddenly the shifting or the movement of the attention getting faster and faster. So you can see a field. If you look at this diagram here, you can see this diagram here. The shifting is from the green to the yellow. So thinking about this information foraging, if you're in the green area, your topic is green, you have to ask you this question. Everybody is moving to somewhere else. Should I go or should I stay? So this is apparently it's a long story, but you can see the references. The story is it's a one theory they found the conclusive the evidence. Everybody said this is very successful pattern. How can we apply this to something else? For another case, everything else remains the same. Just apply to a different mass extinction. Theory remains the same. Methodology is the same. That's a very economic way to do things. You don't have to add lots of resources. Just apply what you have. So this is like the tool. We have the tool. Then we have the tool to something else in addition to what we originally aimed for. So this is the example. We compare how much we can do without domain knowledge. And actually, in this case, the domain expert, they write the same topic. They write review papers, but 2 years later, I think here's 4 years later than us. So in other words, without our domain knowledge, with only these patterns, we can identify, if you read the words, almost equivalent, it's the same thing, identify this field. So you can see how much time we saved to realize this, and you can plan 4 years earlier, you can benefit from that, and so on. Another case for string theory, but here you read what are the reasons they give a word? Again, here we ahead by 3 years. So the award here, obviously identified by experts, but without knowledge, we know this simply because the patterns. So summarized here, and then so just briefly the key points recap. I think I'm still within that 5 minutes. So this is a way to look at science as a complex adaptive system. That means we need to pay attention to the input, but we also need to be aware that not every input is equal. We know that some paper doesn't make any impact, but some other papers, they make huge impact. That's the complexity part. And also the adaptive is we need to look at it strategically, which areas we can make a high impact work, which areas are crowded, which areas and probably no hope if already lots of publications there and the novelty is really hard to claim from those areas. So the value of this put together, we think the mind is responsible for what we see. The mind here in this case, I emphasize we need to know lots about theories about what science change, what science revolution, and what science is supposed to be. We need to know that before we can use any symptomatic tools. So it seems a lot of people assume this tool, I can just take it and use it, and it will tell me something really valuable. But without the support of these theories, what you're looking for, and you're probably going to have a hard time to identify what is valuable. But guided by this, but as I said, the flexibility is you can replace any of these theories with your favorite one. You don't like this, you can replace something else, and then that will translate into what you're looking for. So this is a process of a visual thinking process. It's quite suitable to something like science, so complex. Is the one point doesn't tell you whole story. You have to take the context, everything together as a cloud, as a flock of birds, that level of understanding. So this is why we have this visual analytics, not only limited to the indicators, but looking at the story. So that's why I'm using this story in a very broad sense. You join different parts together, how you can explain something important, something happening. Also, you can use this to guide your own behavior, your own plan. So in this way, we would expect to see a better quality of people's citations and better quality of those peer review outcomes. I think that's it.
Okay, thank you. Good question. Yeah. And come here. Then the acrobatics.
Hello, thank you very much for your talk. Lots of stimulating stuff. My question will be rather general. I'm a philosopher, mainly a consumer of scientometric data. I've only managed to become a co-producer of scientometric data by joining forces with Eugenio, and I acted as a sort of domain expert in some aspect where he did the hard job, like finding patterns, and I was the guy with, oh, this pattern may mean this and that. Now, if I interpret your take on methodological methods correctly, you can still produce a lot of good patterns, and you can grab the data even without domain expert, and also make great predictions. And that I find easy to believe. But what are the limits of having no knowledge of the specific domain or no person who is a domain expert when it comes to explaining, understanding, and interpreting data? And if so, what is the limit of multidisciplinarity that a scientometrician can have? If that's necessary, you cannot explain without proper collaboration in all domains. You need to be confined to your specific favorite discipline or disciplinary groups, maybe. Yeah. I don't know. Thank you.
Okay, thank you. That's a great question. So my point is, we'll be lucky to have domain expert like you. So that's always the case. We have domain experts, but this one will have the advantage to provide you alternative view. So we're doing better homework before we start to talk to you. So better prepared. So anytime you can have this flexibility, we don't take your time before we ask you any questions. But we identify which area is interesting, and then we go check this. So what do you think? Also, we check some examples. We go back to the original authors. We check your paper turned out to be something suspicious in this area in a good way. So can you tell us what's going on here? What do you think is the value? But also bear in mind, sometimes lots of users, they have this kind of question. This is not what I expect. So again, that's the same for domain experts. What do you expect? So you're going to see, if you stay with what you expect, you're losing an opportunity to learn something new. As a domain expert, or as anybody, what you expect is one thing, that's what's in your mind. But you can also open up your mind to find something new that's not in your mind. This is not what I expect, but this is telling us something going on. I need to understand that. Oh, I understand, I make a further progress. But again, here, domain experts, we consider as a luxury, we have that. But on the other hand, is when we have that, even for the domain experts, you need to have open mind. This is very important. What expect is not necessarily, otherwise there's no point to go through this analysis. You know everything I already know. So at least one example we have is with the generative medicine. One of the reviewers asked a question. I don't understand why that's there. I think that's irrelevant. But we won't go deeper, we'll analyze this. Is the reason Nobel Prize winning, the connection there, people had it, and that's starting to make sense. So in that way, domain experts can also learn something because of specialization, because of the training. So that's my answer. Thank you. Very good.
That's another question.
Thank you very much for your inspiring presentation. And actually, whenever I hear that, so I wish we would have those tools not only for lay bibliometrician or those which are familiar, but for everybody, almost on a Wikipedia kind of layer. Yeah. So, but that's more a remark. Yeah, I don't want to burden that on you.
Okay, so I don't need to answer that.
You can answer that. Yeah. So I would be curious to hear how much you have been able in your local environment to let that grow into wider use. My question is another one. I think we are all aware about generative AI and how disruptive that is, and I'm really curious if it already shows up in traces in the scientific communication. You must have thought about it. So have you looked for it?
Yes.
Do you see anything?
Yes, yeah, great question. Yeah, so first, I answer that question, the AI, I was, or I have been really impressed by the AI, the development of AI. Lots of things, like, for example, what is the nature of a cluster? If you have a cluster citations there, usually it's very time-consuming, cognitively demanding to summarize. So we know that we can look at lots of pieces, but it takes a lot of work to join them together to see what is the nature, what they have in common. Here, the AI can tell us something. So again, AI is not replacing what we think, but it's at least provide a version, a reference point, so we can go from there. So we can verify, we can go our own ways, but at least that reduces a lot of the legwork we have. So I will see as a disruptive technology, we probably should have, or it's already people already looking at every aspect of our study to be revisited in different ways by given this new technology. So I have some. I participate some talks, seminars, and workshops. Have already. This may fundamentally change how we do science, how we do research. As an editor, I have experience with getting reviewers, peer reviewers. Is getting harder and harder to have people to spend their time to review lots of more papers, more and more papers, like endless requests to them. I even started to feel sorry. This one I asked 6 months ago. I shouldn't go back to them pretty soon with that. So again, this technology is available there to summarize so quickly, and then eventually you're gonna ask this question: who's behind the paper, the publication? Yeah, reading is generated by AI, or is generated by my real peer researchers? They really put time and effort in it, or is just to summarize lots of things. So that could be positive, could be negative, but I think that's the things we have to face anyway. It stay with us. So, but like more tools we make positive use.
Thanks for the talk. So mine's a methodological question, like the first one. It's a micro question, but I guess it's a general. We can generalize it. When you were talking about some of your analyses, you mentioned you're looking at how a science changes, so how a subfield or whatever changes, and you say we might look at 50 years and see no change, and then extend our analysis for 70 years, and then if need be,
yes,
yeah.
yes.
So I'm more curious and sort of eliciting your response to this than thinking it's a concern, but maybe it is a concern. It seems that method is at risk of looking like the equivalent of p-hacking in other disciplines. So why isn't it, or should we be concerned that this sort of methodological strategy is just a version of p-hacking with all the concerns there?
Well, I'm not familiar with the p-hacking, but we can define it.
Okay, so you change the significance level you're looking for, and then you'll find something statistically significant. So in psychology, yeah. So in psychology, there's wide-ranging accusations of p-hacking, and so you're going to find something. If you don't find it the first time, you just move the goalposts.
Yeah, this is a great question. Remember here, let me give you one example. In 2012, we published a paper called the structural variation theory, and that gives you a tool to watch the areas you currently have a lack of traffic at this point. then you're gonna look for next traffic. You're gonna have a lot of traffic in those areas that's supposed to be important. So that's supposed to attract a lot of attention. Then I heard from one researcher, they said they didn't use p-hacking, they use water injection. And so you inject lots of water, then instead of real science into this, they can something like a game with the you build lots of traffic that you know it's going to bring lots of rewards. So that's one argument. So my answer to that is this is constructive process. It's not only tell you what research is important, but also tell you how you can do it. So imagine if you're really building your work, you build a bridge there. That bridge is not there, but if you can build bridge that bring lots of traffic there, that by itself is a significant research based on our standard. You change the structure, you change the view of people of science. So that's in fact back to the original motivation. Maybe the research can be motivated differently, for example, for p-hacking, but what they actually did end up with something that's really contribution. Does that answer your question? You start with p-hacking, but you end up with making real contribution to science. So that's my answer. If you have like this bridges between the two valleys, if your goal is really, I'm going to have my citation rate up, I just adding those bridges. As a byproduct, you adding bridges, you actually serving both communities on both sides. So that's my thinking about that. So in that way, the risk is probably lower. You can still have p-hacking, but your end product, if you follow this framework, you're going to do something good anyway.
Yeah, short question.
Yeah. You mentioned the case of trying to predict the stuff like the Nobel Prizes. That's an interesting thing because the Web of Science, you know, I don't know if they do it again. They were every year, say, okay, here we look at the bibliometrics and we predict this and that. Okay? I think it's 10 years ago we did a paper called Why It Has Become Difficult to Predict Nobel Prizes. And I think that it cannot work because there's a sociology behind it also. So you can find the best thing. So do you think that with the new methodology, either through block approach or enter citation, that now we have a better way to predict the Nobel Prizes? Because then I would have been wrong, but I don't think I think we have good argument that it has become more difficult for many, many reasons, including the dynamic of science itself, the multiplication, the politics of behind the Nobel Prize, where they have to change they cannot always give that in elementary particle physics. They have to go in solid state. So in fact, we cannot predict, despite what ISI tried to do. I don't believe it. Maybe I'm wrong. So do you think there are new methods that make us more chances to predict the Nobel Prizes?
Okay, so that's a hard question.
Sorry.
Yeah, so the general idea is this. Again, the theme here is this methodology. The advantage of that is not only help you to understand what's going on here, but then help you to plan for your next step. Constructively, if you build those bridges, you may end up with a Nobel Prize because you're making the changes. Do I have time to go back one slide? Yeah. So this is one theory. I think this very fundamental, revolutionary in theory. So the contribution here is really there are two blocks of thinking, and he made that two equivalent. So that's the level of change you can bring to a system. So in that way, Nobel Prize or not doesn't really matter. It's just a contribution here. So we're trying to use this as a framework of thinking. So this is just one of the mechanisms. It's called a boundary building or gateway, brokerage, whatever you call it. But if you can use this one, that will very likely to make a significant contribution there. But what we don't know right now is how many other these kind of mechanisms. This is by building two together, building bridges. That's one clearly. Lots of people doing that. But what other surprising things or mechanism people can repeatedly apply to get good work done? So again, this is probably just the beginning or starting point, and then we can look at are there any patterns from Nobel Prize winning histories to look at are they doing something methodologically you can codify it into this kind of work. So again, I found it really hard to predict who's going to be a Nobel Prize. I found it's a better way to understand why they get it, where they build bridges. Yeah.
I see. Thank you.